Welcome back to Programming for Engineers. And in this class, we will start looking at more advanced features in Python, in particular, how to load and use modules and libraries, and then how to define classes. As you will see, both subjects are much simpler than in C++. So from the Python perspective, the definition of modules or library is much simpler. Those are simply files containing a set of definition statements, and they get stored in a Python file. In this case, we say name.py. The good news is that then once you create those, you just need to write the directive import and the name of the file without the extension, and that will import and execute the module itself. So the module name becomes a global variable, and then under that name, basically it's the equivalent of a C++ namespace. You can access all the functions defining that module. Also, there are ways to access just if specific functions directly or load all of them in the global namespace. That's not really recommended in general for large projects, but for small activities, that could be kind of good enough. So let's look at a couple of very simple examples. For example, in Python, we have the module math that contains a set of math functions like square root and so on. And so one simply indicates import math, and this is again a standard module. And then you can access the square root using math.sqrt, for example, of 4. If you expect to use a particular function repeatedly and you don't want to continuously put the prefix of the module, you can also say from math import square root, which means implicitly, so you want to import that particular function and make it available in the current namespace. So let's take a look directly from the Python interpreter. So let's say here we have import math and execute. So import math square root of 4, and you have the result. Now, if I type sqrt of 4 without the prefix, I get an error because the function doesn't exist in the global space. But again, if I do it with the prefix math dot, the function do exist. With this variation of say from math import square root, now the particular function is part of the global namespace. So if I do square root of 4, the function is actually available. For libraries that we can use often and for which we don't want to import all the function namespace, it's convenient to use this aliases. So let's say use import numpy and you say as np. So from that moment on, when you're instead of referring to numpy as the name of the library, you can use np. And you can do the same for other libraries as well. So this can be convenient when you use it repeatedly, so you don't have to type long sequences, but you still keep the symbols separated from the rest. So here, for example, if I were to do import math as mt, and so when I go and do the square root function, I can do mt dot square root, and that works. So even if the name of the library is very long, I can do a very brief shortcut that makes it easy to use in practice. So one should not be too concerned about making names of the libraries that are short. Again, make them understandable. That's the most important part. In fact, you will see that in most example, people that use NumPy, they always import it as NP, as an alias, and so that they can use it directly. So now there is a way to look at what symbols do you have in your namespace, and the dir function does exactly that. So for example, here I can do dir open square, open close parentheses, and then I get the list of symbols in the namespace. But I can do it also for a particular library, and I get the set of symbols inside that library. So let's try it out just for simplicity. So here you might want to think what symbols could be. There are a couple of symbols that you know are certainly in the global namespace, because those are symbols that we have imported and used. So all those with the underscore underscore at the beginning, at the end, are kind of special symbols that Python creates in every space. But here you see I have math because I imported math. I have a square root because also we did the from math import square root. And also I have empty because I imported math with the alias empty. Now, if I want to look at what's in a particular library, so here I did the empty, which is the alias for math. And so here I have the usual kind of general symbols there, but then you have all the various typical function that you would expect in a math library, from sine, cosine, and so on and so forth. Also, no surprise, if I do dir math and dir MT, I get the same result. So here it's just a way to access all the symbols and understanding how they work. So if we start using with popular libraries like NumPy, SciPy, and Matplotlib, we'll see how quickly and easily one can build interesting, for example, plots with just a few functions, a combination of NumPy and Matplotlib, and that we'll see in the next class. Now, a construct that we saw in C++ is the one of classes that has the same general function where you can group together data and methods to represent a kind of a new type, and you will have a bunch of member variables and constructors so that you can actually manipulate those at a high level. Now, we saw in C++ how precise the language wants to be on that front to avoid many possible mistakes. As usual, the philosophy in Python is actually to be much more forgiving and having a few conventions that allow you to build things easily and quickly. So here is a definition of a class. We'll test it then. Let's say class course. And now this can have a set of local variables. Here we say, let's say university equal Utah. It's a variable that will be shared with all the elements in the class. And then we have a constructor. So by default, the constructor is this function that is called underscore underscore init underscore underscore. You saw already in the namespaces that those symbols that start and end with double underscore have a set of standardized functions. They are actually just regular variables in the language, and simply there is a understanding that certain functions are built for certain purposes. So when a class is created, First thing is that this function is called. And so here we have the function. The first parameter of all the functions in a class are have a parameter self, which refers to the current instance of the class. So any local variable can be referred to by the self. So for example, if I create now an element of type class, I can give name and year. And so I can save it in local variables, self.name and self.year, and assign the value. And so that gets recorded. And then I can define a method. In this case, just print the value in the class. And so I have print self. So this parameter should always be there. Otherwise, this function wouldn't know how to refer to elements in the instance of this class. And in this case, we simply print the name, year, and the university. Notice the mix of the name and year come from variables created in the constructor, while university is a global, a shared variable in the class. And so if one uses this in practice, we'll see, so you can do create an instance of a class, let's say prog course programming 2017. Now the value of prog itself, it's actually an instance of a class. So you need this, you find as a value this kind of cryptic descriptor, which means it's an instance of a class. I can create another one, similar result, but then I can call a method for each of those, and for example, print the values inside. So let's try and use this in practice. So let's say here I take the first part of the definition. So let's say I do this here. Now I go, let's always be careful with the tabbing. So I created the first, the constructor, then the print method. Notice that here you have the dot dot, so it's continuing, it's not getting the new prompt, so it's everything continue until evaluation. And so now course is defined, and here you see the value of course is the definition of a class itself. Now we can start using it, and so the first, the variable prog, so let me do it again, prog is assigned a class with those two values, and then prog itself has value instance. This is the value basically of a reference to the class, is a particular instance. Notice that the class itself is simply the definition of the class, while this one with a specific object in a particular location is the actual class instance. So here, if I do now prog print, oops, always. So here you see programming 2017 Utah, right? And now I can create another instance, other. Again, it creates a new object. Notice that the reference of the object is different. So it's clearly those are two distinct instances. And then I can do the print for the second object, and you see topology Utah 2018. So this is kind of a very simple way to create classes. And now from what you learn in the C++ base, kind of all the same concept kind of have the same validity. It just except that here everything is kind of much easier to handle. And in particular, in next class, we'll see how to use also more complicated libraries like NumPy and Matplotlib, and see how we can get more use out of those. Thank you.